Suffice it to say, facial hair, me, doesn't... Does David Suzuki have a beard?
Yeah.
Okay, I'll have to give you that one.
Yeah.
Like there are some beard growing ethnicities who have like great beards. I don't think the Asian ones have a great culture of beard growing. It's like a goatee.
Buddhist monks grow great beards.
Do they?
I'm pretty like I feel
I
like
thought Buddhists are bald.
Yeah.
they're bald, but then they grow.
Oh, I thought you said monks. My bad. What about samurai?
Search up
Do samurais have beards? I haven't met one.
for a while. Oh, check this out.
I guess the Ronin would have to have beards. Anyways, I think we're slightly off topic. Okay, let's go through these. I'm going to go through them on the order I wrote them on the board, just so these ladies in front don't stress out. Okay, exercise.
But can we do the one you skipped? The one you missed? You erased one that you...
That's the third one here. I'll get to it, yeah. So am I recording? Just make sure I have all that beard conversation. Great. Okay, so sum n equals 1 to infinity, n factorial over n to the power of n. And I'm going to go through this in detail, so maybe you can copy my steps, right? So here's step 1. I hate doing this, but maybe it will help you. We have to write down what the nth term is. All right, step 2. I guess you have to decide what test you're going to use, but I'm going to use the ratio test here. So step 2, ratio test. We need to figure out what the absolute value of an plus 1 over an is, and then take the limit. So an plus 1 over an, that's going to be n plus 1 factorial over n plus 1 multiplied by n to the n over n factorial. This is further equal to, let me see what I got here. All right, so we're just going to kick out one of those terms, n plus 1 times n factorial over, and the bottom, I'm going to separate it like this, n plus 1 to the n plus 1 to the n, and then I'm going to multiply that by n to the n over n factorial. So what cancellations do we get here? Well, we get that n plus 1 and this n plus 1, this n factorial and this n factorial. So in the end, we're left with n to the power of n over n plus 1 to the power of n. Now, this is something that even I screw up all the time, so don't be like me, do it properly. So we've determined that we've simplified the an plus 1 over an absolute to this. So now we need step 3, we need to take the limit, right? We need the limit as n goes to infinity of n to the power of n over n plus 1 to the n. Now, if these exponents weren't there, I could say something like, oh, let's just forget that n exists and take the limit. That's the wrong way of thinking. You can't do that when there's an n up here. Right? If this was constant, then it would work. But this is not constant, so we have to treat this a little bit different. So I hope you can remember. No, I thought someone said professor. Okay, so we have to remember how to do this one. So how do we do this one? So I guess you could use, you could take the ln of it, but we can do it more directly. So if I'm just going to write it like this. So we have the limit of n goes to infinity, and this is actually a fraction, n over n plus 1 to the n. And then I can simplify this fraction a bit, and you'll see why. I'm just going to factor out 1 over n over 1 over n. That's a silent 1 that we can utilize. Multiply that by n over n plus 1 to the n. This is going to be the limit of n goes to infinity of what? Well, 1 over 1 plus 1 over n to the n. And what's this? I'll write one more. You get 1 over the limit of n goes to infinity of 1 plus 1 over n. Oops, to the n.
It's 1.
Nope. This is e. is one of the special ones you have. You have that 1 over 1 plus 1 over n to the n goes to e to the 1. No, to the n. So that to the 1. It's 1. Okay, so this ends up going to 1 over e. So don't forget you have these special limit identities. So 1 over e, is this greater than 1, less than 1, or equal to 1? Is it equal to 1?
No.
That's pretty clear. E is at least 2, right? So 1 divided by e has to be less than 1 strictly. Which means what? This is convergent by ratio test. Yes?
You know how you brought like a head? No, in the beginning, where did you get that?
Which one?
The n factorial? That
Yes?
crossed out. No. You changed the n plus 1 factorial to the active.
Oh, right. N plus 1 factorial, by definition, is n plus 1 times n factorial. Who was I talking to? Yeah, remember? Well, like 7 factorial is 7 times 6 factorial. That's how it's defined.
But then wasn't it you said n minus 1?
Well, n plus 1 minus 1 is n.
Oh.
Right? So if this, I could write n factorial as n times n minus 1 factorial. But that rule applies for how far up you just have to remove 1 and you can pop it out. Right? So that's what happened there, right? This is n plus 1 factorial is n plus 1 times n factorial, this guy. Does that clarify things a bit? Cool. Yeah, you're going to have to do that a lot. Right? So that's why I want you to really understand it. In fact, I want you to get so comfortable with this that you don't actually have to write this step. That you can just say n plus 1 factorial divided by n factorial is n plus 1. Right? It's obvious. Like 7 factorial over 6 factorial is 7. Like you're canceling out everything afterwards. Like once you get a little bit comfortable with these. These factorials are way easier to use than the sum, for example, because you're just multiplying like a sequence of numbers that just go down. Any questions about this? Yeah.
So if the numerator here was not 1, right? If it wasn't 1, would you like take the limit of the top as well?
No, if this was a 3, then I'd have a 3.
If it was like an n.
If it was an n, then that would be a different story, right then. I don't know what I
Are
would.
you taking the limit of the top or just the limit of the bottom?
Both,
Okay.
right?
Okay.
Like I'm taking the limit of both,
Okay.
but the top is 1, so I've just tried to isolate this because you will be able to find this exactly in your book. Like I said something like 1 plus 1 over n to n to infinity gives you e. So I just wanted to make it really explicit. I could have jumped from here to here, but then I think everyone would ask where did that e come from? So I'm trying to catch that and make it very obvious. Can I move the board? Okay. I'll use the hidden one. The forbidden board. We'll do the next one. Okay, so here we have, oh, nice and clean. N equals 1 to infinity of 2n factorial over n factorial squared. Okay, so step 1 is what? What should we do first? All right, so we should figure out what an is. So step 1, an is equal to 2n factorial over n factorial squared. Okay, what test do you want to use? You think we should use the nth root test? Or I think we should use the ratio test. I don't see any powers, so let's use the ratio test, which means we need the ratio. an plus 1 over an, absolute value. Okay, so first notice that every an is positive to begin with. So we can drop the absolute brackets right out of the gate. So I'm going to write this. Again, what do we have? We have 2 n plus 1 factorial. Let me just be very careful about how this was written. Right, because this is like this. Yes. Okay, 2 n plus 1 factorial over n plus 1 factorial squared multiplied by just the reciprocal of this, which is n factorial squared over 2n factorial. All right, let's try to simplify this a bit. So here, what do we have? We have 2n plus 1 times 2n factorial. All right, just be careful with how you bracket these things. On the bottom, we're going to have n plus 1 squared, n factorial squared. I skipped a step, but hopefully you can follow, right? I'm going to get 2 n plus 1s from here, because they're squared. I'm multiplying 2. Well, you can also think of it like this. N plus 1 factorial goes to n plus 1 n factorial. If I square that, that square is just going to distribute across the terms. Here, we're just going to get an n factorial squared. And then here we're going to get a 2 n factorial. And I'm being really careless. Just shows you how easily you can make mistakes if you're not being careful. So just be careful with how you're bracketing. Okay, so what do you get? What are our cancellations? Well, you got an n factorial squared, 2n factorial, 2n factorial. So what are we left with? Let's just make sure that I'm doing it properly. We are left with, let me see. What have I done wrong? I just want to make sure that I'm not. Did I miss something? Anyone see a mistake?
Can we take out one of the n plus 1 in the denominator if it's squared? Can we cancel out the 1?
All right, well, we can also cancel out one of these. Okay, let's continue. I think I did it a little bit differently in my notes, which is why I'm getting confused, but I don't think I've made any mistakes yet. Someone observed that this can cancel with this, so that just cancels one of those terms left. So what am I left with? 2 over n plus 1? Now, I know this is wrong because I set this up to diverge. I must have made a mistake. Let me just check. And if you want to be very kind, you can try to help me find my mistake. Oh, I see my mistake. All right, will you permit me to start over?
Yes.
Okay. Here's the mistake. You see it?
You put the thing inside.
I put it inside. All right. So this is how careful you have to be. Right? You move one thing over. Sorry about that, guys. It's tough to keep something. Okay. So I'll do this and then I'll let you guys go and you can look at the last one in the book. But I really want to make sure to get this done and do it properly. Okay, so we know that then an plus 1 over an, that's going to be 2 times n plus 1. All of this is taken to the factorial over n plus 1 factorial, that is squared, multiplied by n factorial squared over 2n factorial. Okay, so this is going to be what? We're going to get, let me see. Up here, we're going to get, well, this is 2n plus 2. Why did I do it in here? This is 2n plus 2 factorial. This is n plus 1 squared, n factorial squared, n factorial squared over 2n factorial. Those will cancel with this. Now I just want to get rid of that 2n factorial. So this is the tricky part. What's left if I divide this by this? Maybe I should just write out a few of the terms. Yeah, I wouldn't ever write this out really, but you get this. Jeez. Right? This is 2n plus 2 factorial. I can count down. And then that's going to be over n plus 1 squared, 2n factorial. That will cancel with that. And what are you left with? Okay, we're left with 4n squared plus, square the first, double the product of the middle. That is 8n plus 4 over n squared plus 2n plus 1. What's the limit of this as n goes to infinity?
Why is it plus 4?
They're not the same. Professor.
Oh,
They're not
geez.
squared.
Yeah, so it's 2n, that's 4n squared, 2n, so that should be, 2n, and then 4n, that's 6n plus 2. Okay, thank you. Yeah. What do I get in the limit? Which is greater than 1, yeah? Which means what? Divergent sum by ratio test. All right, well, sorry I got it wrong the first try, but got it right on the second. So the thing that matters is that we persisted and got it correct. So don't feel bad if you screw it up. If you move one of these factorials into a bracket, it's going to throw everything off. So you got to be really careful when doing these things. Because even I screw them up from time to time. All right, so I'll be in my office. Buy YouTube, like, subscribe. Hit on my Patreon.